Okay, welcome to our class. We are studying periodic table. In that, we are going to discuss periodic properties. We have some important periodic properties in this chapter. So far, I have explained atomic size, definition of atomic size, and what will happen atomic size in group and also in period. We move from left to right. And we completed ionization energy. And also we studied the following topic, that is electron affinity. All those we discussed in last class. Today I am going to teach fourth periodic property. That fourth periodic property is called electronegativity. Write down electronegativity. 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 So electronegativity in short notation it is EL. Electronegativity in short notation you write EL. This is electronegativity. Okay. First of all, we want to know the definition of electronegativity. What is electronegativity and what happens in period and in group, that we are going to study now. So you write down definition first. I will explain very clearly. Write down the property of the property of the property of to write down the property of tendency, the property of tendency to attract electrons, to attract particularly bonded electrons, to attract bonded electrons, the property of tendency to attract bonded electrons, by an atom, in hetero molecule, is called electronegativity. So how can we define electronegativity? Means it is a property of tendency to attract bonded electrons by an atom in a heteromolecule. By an atom in a heteromolecule is called electronegativity. So it is easy to understand by taking example. See, I write here one example. See, HCl, H bond Cl. So H bond Cl, this is called what? Hydrogen molecule, hydrogen chloride. This is called hydrogen chloride molecule. What we call HCl, hydrogen chloride. So in hydrogen chloride, actually it is hetero molecule. It is called what? Hetero molecule. Why it is hetero molecule means here in this molecule, one atom is hydrogen and other one is chlorine. In this molecule, one atom is hydrogen and other one is chlorine. That means molecule which is having two different atoms. That's why it is hetero. Hetero means different. So in this hydrogen chloride molecule, what happens? This chlorine atom can attract bonded electrons towards itself. As a result, what happens? See, H partial positive plus N partial negative. So the property of tendency to attract bond electron. This is called bond. This is bond. Here, this bond which is made up of two electrons. Bond is consisted of two electrons. So this bond is a bridge of two electrons. That means it carries two electrons. These two electrons taken by chlorine. These two electrons taken by chlorine. That means chlorine can attract bond electrons towards itself in a heteromolecule. The property of tendency to accept the bonded electrons towards itself, this is not what electronegativity. This tendency is nothing but electronegativity. By itself, what happens? So, due to its high electronegativity, chlorine attains negative charge. So, this property of tendency to attract, accept electrons towards itself. This is not what electronegativity. This property is not what electronegativity. Right? Okay. For example, this is example one. You can take example HF. Here what happens? This is hydrogen fluoride. HF, hydrogen fluoride. Hydrogen fluoride. In hydrogen fluoride, what happens? This bonded electrons attracted by fluorine. Okay. This property of attraction, this property of tendency to attract the bond electrons is called electronegativity. By this, what happens? H becomes less, fluorine taken bond electrons. That's why fluorine becomes partial negative. This becomes partial positive. So the property of tendency to accept the bond electrons by one of the atom in the heteromolecule is called electronegativity. Okay. So electronegativity is one of the periodic property, no doubt. So we will see after completing this, we will able to study what happens electronegativity down the group and left to right in period. That we will see. Just you write down. Completed, you are writing. Okay. Write down. Generally, electronegativity, 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 electronegativity decreases, electronegativity decreases down the loop, down the loop, down the loop, because atomic size, because atomic size, because atomic size, because atomic size increases, because atomic size increases. This thing you ought to remember. As size increases, what happens? Distance increases, so that electronegativity decreases. So generally, electronegativity decreases down the loop because atomic size increases and nuclear charge decreases. And nuclear charge decreases. Nuclear charge decreases. Okay. In periods, electronegativity En increases from left to right, from left to right, from left to right, from left to right. Because why? Because size decreases, thereby nuclear charge, nuclear charge, nuclear charge increases, nuclear charge increases. So the low size the atom, low size atom. So the low size atom attract bond electrons towards itself, towards itself, towards itself. So I give you one relation for easy of your understanding. What is that? Electronegativity and atomic size inversely proportional with each other, and nuclear attractions. What is the nuclear charge? Nuclear charge, NC, nuclear charge. This relation you have to remember. Electronegativity is directly proportional to nuclear charge and inversely proportional with the atomic size. Is it clear? So, for example, in group, what happens? In group, this is group, in group, what happens? Electronegativity EN decreases, in decrease. But in period, you can take this period. In period, what happens? Electronegativity increases. Electronegativity increases. Why electronegativity increases? NC increases. Nuclear charge increases. Okay, here nuclear charge decreases due to NC decreases. NC decreases. That means nuclear charge and electronegativity both are directly proportional with each other. If nuclear charge increases, automatically electronegativity increases. That thing you are doing. So whenever nuclear charge is more, low size atoms should have more nuclear charge, and that can have more electronegativity. You write one statement. Low size atoms can have more nuclear charge. Can have more nuclear charge. Can have more nuclear charge and more electronegativity. More electronegativity. More electronegativity. That means this atom attract bonded electrons, strongly. Okay, so all these you can easily understand by observing, by taking examples. I give you examples. I will explain the same thing along with examples. You write down. Completed this matter. Have you completed this? Write down. Write down. So nuclear charge NC is directly proportional to electronegativity. This thing you will remember. Nuclear charge NC is directly proportional to electronegativity. So whenever the atom moves, can have more nuclear charge, can have more electronegativity. That's all. Completed this one. See, I give you an example. See, you know 50 group elements. I write here 50 group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. This is group, you know. Then in 60A, the first element is oxygen. In 70A, the first element is chlorine. So this is nothing but period, you know. Period, which period it is? Second period. Okay, this is fifth group, you know. This is group. Okay. See here, when we move from top to bottom in group, what happens? Electronegativity decreases. Electronegativity decreases. You remember this. Electronegativity decreases. As size increases. As size increases. That's why. As size. But here is the case in period. What happens? En increases. En increases as size decreases. As size decreases. As size decreases. Okay. So you can observe this. Among nitrogen, oxygen, and fluorine, which one is more electronegative? Nitrogen, oxygen, fluorine. Which one is more electronegative? Fluorine is more electronegative. More En. More electronegative. Because when we move from left to right in period, electronegativity gradually increases. Because size decreases, thereby nuclear charge increases. Clear now? Okay. Down the group, what happens? Electronegativity decreases. So among these, so in between nitrogen and phosphorus, in between nitrogen and phosphorus, nitrogen is more electronegative. Nitrogen is more electronegative than phosphorus. Why? Because this is low size. In between nitrogen and phosphorus, this is low size. That's why it is more electronegative. But in between nitrogen and fluorine, which is more electronegative? Fluorine is more electronegative because this is low size. That means low sized atoms can have, I write here, see, low sized atoms can have more nuclear charge and more electronegativity. That means that atom can attract bonded electrons towards itself strongly. Clear? Did you understand this? Okay, next. Next point you write down this. Generally, non-metals are having electronegativity property. Generally, non-metals are having electronegativity property. So that non-metallic character is also same in the order of electronegativity. Same in the order of electronegativity. This thing you remember, very important. That means generally non-metals are having electronegativity property, so that non-metallic character is also same in order of electronegativity. Both are same, you know. Electronegativity and non-metallic character both are same. Did you write this? I want to remove. So here you remember, this is group, you know, this is group, this is period. Okay. Just now I said here what happens? Electronegativity En is directly proportional to non-metallic character. NMC is non-metallic character. Okay, NMC means non-metallic character. Both are in the same order. So what happens when we move in group NMC non-metallic character increases. NMC decreases, non-metallic character increases. In period what happens? NMC increases. NMC increases, which is in the line of what electronegativity, you know, just now I said. Okay, is it clear? NMC means non-metallic character. NMC means non-metallic character. So non-metallic character and electronegativity both are in the same line. Here down the group what happens? Electronegativity decreases, NMC also decreases. In period electronegativity increases, that's why NMC increases. Clear? Okay. So I give you one example. Boron, carbon, nitrogen, oxygen, fluorine. Okay. Among them, example, among them, which one is more non-metallic, and more electronegative atom? Tell me answer. What is the answer here? Boron, carbon, nitrogen, oxygen, fluorine. Among them, which one is more non-metallic and more electronegative atom? Which one? Tell me answer. What is the answer here? Tell me.
Fluorine.
You are right, 100% right. Good, very good. Answer is fluorine. Fluorine is answer because low size, and more nuclear, more NC. Low size and more NC. That's why fluorine is more non-metallic and more electronic. 100% you are right. Very good. Okay. Now I think you did understand well concept. Okay. With this we completed two properties. What is that? Electronegativity we finished just now, and also non-metallic character is also over. Okay. Then after completing this next periodic property, I am going to explain next following periodic property, that is electropositivity character. Okay, I want to remove this. Completed your writing? The next following property, that is electropositive electronegative character or electropositive character. Electropositive character. So I want to explain the definition first. What is electropositive character? Here is a very simple thing, like just now we studied electronegativity, no? Just we studied electronegativity. So now we are going to study electropositive. Both are reverse with each other. Once you understood electronegativity, very easy to understand electropositivity. Why? Because both these two are reverse with each other. So you write down the property of tendency to lose the property of tendency to lose the electrons from an atom is called electropositive character, ET, electropositive character. That is simply represented as EP. So electropositive character is abbreviated as EP. EP. Okay, that is called. So tendency to lose the electron. Tendency, the property of tendency to lose the electrons from an atom, or from an atom or by an atom. From is also right. From or by an atom. Both are right. From or by an atom is called electropositive character, EP character. EP character. So I write one important note here. Remember, EP electropositive and electronegative both are reverse with each other. Both are reverse with each other. Both are reverse with each other. So what the relation we have electropositive and electronegative relation like this. Inversely proportional with each other. Okay. So here you write down generally metals can have tendency to lose the electrons. To lose the electrons. That means all metals are having electropositive character. Electropositive character. That means here metallic character is directly proportional to electropositive character. This thing you have to remember. MC is directly proportional to EP. MC is directly proportional to EP. Both are directly because metals can have the tendency to lose their electrons. That means ordinary metals can have the electropositive character. Both are having direct relation with each other. Okay. So now we will see what happens electropositive and metallic character down the group and in period. That we will see now. Okay. But it is very easy to understand. Why? Because already we studied what is that reverse phenomena, electronegativity. Okay. So from that electronegativity down the group, what happens? Electronegativity decreases. So that electropositive character, what happens? Increases. Reverse with each other. This is very easy. Right. Right now in group electropositive character increases down the group. Because metallic character increases. Metallic character increases. But in group, this is group, no? But in period, this trend decreases from left to right. Why? Because non-metallic character increases. Because NMC increases. Okay. Whenever NMC increases, what happens? Electropositivity decreases. If NMC increases, electronegativity increases. You know very well. Do you understand this? Okay. For example, I take first year group. You know this. What are first year group elements? For example, lithium, sodium, potassium. Come to second year, beryllium, magnesium, calcium. What about third year? Boron. What about fourth year? Carbon. Like this. So here what happens? This is group, you know. This is group. So in group what happens? Electropositive and metallic character increases. Ep increases. In the sense metallic character increases. Okay. In between lithium, sodium, potassium, which one is more metallic? Potassium is more metallic. Down the group increases. Potassium is more metallic than sodium than lithium. But when we move from left to right, what happens? Ep decreases. Ep increases. Why? Because energy increases. So in between, among them, lithium, beryllium, boron, carbon. Which one is more electropositive? Lithium. Lithium is more electropositive. Okay. Have you understood this? Right on. So here I write here among lithium, sodium, potassium, comma, among lithium, sodium, potassium. Potassium is potassium. In the sense A is more electropositive, more heavy, more electropositive, and more metallic. More metallic. More metallic. Why? Because down the group what happens? Metallic character and electropositive increases. But among lithium, beryllium, boron, 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 lithium. Lithium is lithium. Li is more Eb, more electropositive, and more metallic. And more metallic. Did you understand this? So down the group, what electropositive character increases, metallic character increases. But what about electronegativity and non-metallic character? Those are decreases, reverse with each other. When we move from left to right in period, electropositive decreases, electronegativity increases. Non-metallic character increases, metallic character decreases. Both are reverse, you know. Okay. So far I have been explaining so many periodic properties. What we are discussing so far, just one more time I remind the headings. What is that? So far I explained atomic size. Okay, just you check your notes. Check your notes. Atomic size. After atomic size, we discussed ionization energy. After ionization energy, we studied electron affinity. After electron affinity, today we are studying electronegativity, non-metallic character, electropositivity, and also metallic character. Okay, these are the periodic properties we are discussing so far. Let I stop here. The remaining following topic we will study in next class. Okay. Thank you. I stop here.